Hello. In this video, I'm going to give a demo of DeduceIt, a research project at Stanford University for helping students learn formal systems in online classes. The basic idea behind DeduceIt is to allow students to work through formal derivations and to have their improving technology that will check that those derivations are correct, so that you can actually learn the details of how formal reasoning works. So let's take a look at an example here. So here is a little exercise in algebra, and our goal is to prove that x is equal to 11. All right, that's what we're trying to accomplish. And where we start is with the equation 2 times x plus negative 4 is equal to x plus 7. So in general, there could be more than one initial given assumption. In this particular exercise, there's just one. And we want to start with that equation, and we want to prove that x is equal to 11. And to get there, we're allowed to use any of the rules that are listed here that I'm circling with the mouse. And these rules are divided into two kinds. There are the required rules, which is this first set here at the top. And the required rules are required. So whenever we have a step of our derivation that uses one of these rules, we have to name it explicitly. We have to show that step explicitly. And then there are some rules that are considered free. These are the rules we don't have to show. So for example, we don't have to show all the steps involving associativity of addition and multiplication. Presumably our instructor has decided we already understand that, and we're allowed to skip over those steps, and the system will try to fill them in. So these rules down here, we can show them if we like, but they're not required. We're allowed to skip these steps. All right, so let's begin working on this. And every step of the derivation is going to have three parts. It's going to have a conclusion, so something that we are proving at this particular step. Then we're going to have the justification, so the rule from which that step follows. And then finally, what previous facts we're using that we already knew to be true. All right, so what we started with, what rule we applied to it, and then what we concluded from it. All right, so what can we do to make progress in this example? Well, one thing we could do is we could add 4 to both sides of the equation. Okay, and why is that justify? What rule are we using? Well, that's the balance equation using addition rule up here, which says it's okay to add the same thing to both sides of an equation. So we would select that rule out of the list of possible rules. Okay. And then what assumption are we using? Well, there's only one thing that we've got at the moment, and that's the initial given that we began with. All right, so here we have one step of our derivation. We think this is right. We click Update Proof, and the system comes back and says, indeed, yes, that was a valid step of the derivation. Okay, so now let's do another step. Well, actually, let's see what would happen here if we did this balance equation step incorrectly. Let's say we didn't add the same thing to both sides. And so let's try that out. And what do we get? Well, we see that now it comes back colored red, indicating there's something wrong, and we're not given another step here to fill in, okay, because this was an incorrect step. But we also see there's this little question mark icon here, and we can click on that. And it tells us something about what went wrong, gives us some advice, says that balancing an equation means you have to add the same value to each side of the equation. Okay, so with that advice, presumably we'll be able to figure out what we did wrong and correct this step and get back to a place where we're on track. Now, I should say that there's not always advice available for every incorrect step, but if it is available, you can click on that and get some idea of what it is you might have done wrong. All right, so now let's go on. Let's take a look at this and see what we could do. Well, we could try to simplify the left-hand side here. So that's equal to 2 times x on the left-hand side. And the right-hand side, x plus 7 plus 4. And we think we can do this here because 4 plus negative 4, well, that's just adding constants, and that's one of our free rules. Okay, so we're allowed to add up constants, and getting the 0 there should be something we can do for free. All right, and that follows from our previous step. So we select that, and now we can do an update. And it comes back and says, oh, we did something wrong. So this doesn't immediately follow from the previous step. And there's actually a hint here, so we can see why. And we see, oh, so additive identity is a required rule. And so what mistake did we make? Well, it was okay to add 4 and negative 4 together and get 0 and not show that, because that was just adding multiplying constants. But then the subsequent step where we said that 2 times x plus 0 is equal to 2 times x, that is something we're actually required to show in this exercise. So whenever we use additive identity, we have to explicitly say so. So we can fix that by saying that yes, this rule actually, this step actually follows by additive identity from the previous one, and all the other rules that were used in that step are free, and so we don't have to name them. All right, so now we can go on. We can also simplify the left-hand side. We might as well clean that up. And this is just free rules, so we don't have to say exactly which rule we're using. And I think I didn't take the update there. Okay, so now, I guess I hit it twice by accident. So let's just get rid of one of these steps. Okay, so now what's the next step we're going to perform? It looks like we need to bring x over to the left-hand side. So we're going to add a negative x to both sides. So I have 2 times x plus negative x is equal to x plus 11 plus negative x. Okay, and that's again the balance equation using addition rule, and that follows from our previous step. Okay, and we can get rid of that one. All right, and when we update that, that works just fine. Okay, and now we can do some simplification on the left-hand side. On the right-hand side. All right, because all of this over here is just equal to 11. Okay, and then we're having to use x plus negative x is equal to 0, and then we're just adding 11 and 0, so that would just count as adding up constants. So this should follow from additive inverse from the previous step. All right, if we update that, yes, that worked out fine. And now we just have to work on the left-hand side. We got 2 times x plus negative x. And in order to get that into a form where we can simplify it, we're going to need to use the distributivity rule. We're going to need to pull out the constants that are in front of the x's. And so we can do that. We can say that 2 plus negative 1 times x is equal to 11. And so we're using distributivity there, but we're also using the unary negation rule that says, negative x is equal to negative 1 times x. But that's a free rule, so we don't have to worry about that. So the only rule we need to name is the distributivity rule, and that follows from the previous step of the derivation. We update that. Okay, and now we're just about there. So now I think in one step we can do the simplification. We can subtract 1 from 2 and get 1, and then we have 1 times x is equal to 11. And that's the multiplicative identity, which is a required rule for this particular exercise. Follows from the previous step, like all the previous steps. And now we're done. And now we've proven x equals 11. The system knows we have finished the assignment. And that is the basic idea behind DeduceIt. And while this particular example was algebra, this can be done for any kind of formal system where you can present the kinds of exercises you want to do as a set of rules, and the students are supposed to derive some kind of goal using those rules.